about kinetic energy and work. Are you guys ready? If yes, get your notebook and pen to take down notes and listen carefully. To begin today's lecture, let me first give you a bit of background information on the topic. Energy in physics is the ability or capacity to do work or to produce change. It may exist in potential, kinetic, thermal, electrical, chemical, nuclear, or other various forms. There are, moreover, heat and work, which is energy in the process of transfer from one body to another. In this video, however, we will focus on energy in motion, or kinetic energy. The energy associated with the motion of a moving object is called kinetic energy. It is defined as 1/2 the product of a moving object's mass and the square of its speed. Given the first equation, K is equal to 1/2 m multiplied by v squared, wherein K is equal to the particle's mass and v its velocity or speed. Now, try to solve this using the formula we discussed earlier. Determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meters per second. In the problem, you are given a mass of the roller coaster car which is 625 kilograms and a speed of 18.3 meters per second. Speed and mass are given, thus this problem is very easy since you just need to substitute these values to our formula. Now try to solve this one. The kinetic energy of a boat is calculated at 52,000 joules. If the boat has a mass of 39,000 kilograms, with what velocity is it moving? The answer to the problem earlier is as follows. The square root of 52,000 joules divided by the quantity of 1/2 times 39,000 kilograms equals the square root of velocity squared. The final answer should be velocity is equals to 1.6 meters per second. Did you get the same answer? If yes, good job! Let's solve some more problems. Now, let's make it quite challenging for you. A rocket with a mass of 1.5 times 10 raised to 4 kilograms was launched and accelerates at 220 meters per second squared, or 29 seconds, from an initial speed of 5,200 meters per second. A. How fast will the rocket be traveling after the 29 seconds? And B. How much kinetic energy has the rocket gained? Are you able to solve it? If not, let me discuss it for you. In the problem, you are given the mass of the rocket, which is 1.5 times 10 raised to 4 kilograms, an acceleration of 220 meters per second squared, a time of 29 seconds, and an initial speed of 5,200 meters per second. The first question is, how fast the rocket will be after 29 seconds. If you will analyze it, you are asked to find the final velocity, which you can get by using the formula of constant acceleration motion. Now, let's answer the second question. Since you are given an initial velocity and are able to calculate the final velocity, we will just directly substitute this into our formula of kinetic energy. But wait! How are you able to substitute this into our formula? If you don't know how, I will show you how. Shocked? I did not introduce a new formula. I only reuse our formula for kinetic energy. But since you were given an initial and final velocity, you could use or apply the formula in getting average velocity, which is final minus initial. Now we are done with kinetic energy. Let's move on to our second topic, which is work. The word work as used in physics has a narrower meaning than it does in everyday life. First, it only refers to physical work, of course, and second, something has to be accomplished, defining work as force times distance. As usual, we will measure the distance in meters, but we haven't talked about our units for force so far. Just remember Newton's second law. Force is equal to mass times acceleration. The natural unit force would be that force. The unit for force is N, or Newton. The downward acceleration of a freely falling object, 10 meters per second, is often written G for short. But to be precise, G is equal to 9.8 meters per second. Now, we have a mass of m kilograms, we know its weight will accelerate at g if it's dropped, so its weight is the force of magnitude, or mg, from Newton's second law. Since work is force times distance, the natural unit of work would be the work done by a force of 1 Newton pushing a distance of 1 meter. This unit of work is called 1 joule, in honor of James Prescott Joule, an English brewer and physicist. Now, let's solve some problems using the formula above. How about we start with an easy one? 25 newtons of force is applied to a box, and the box moves 10 meters. Find the work done. Easy question, right? You are given a distance and force, thus you can directly substitute it to our formula. Now try this one. A block displacement cos of a force in a horizontal surface is 13 meters, and the work done by the force on the block is 15.6 joules. Find the magnitude of the force. Now here's the solution. We start with our base formula of work is equal to force times distance. Subbing our values in, we have 15.6 is equal to F times 13. Now what we're looking for here is obviously force, so we transpose that, leaving us with the equation of F is equal to 15.6 divided by 13. Punch that value in and you should have the final answer of F is equal to 1.2 newtons.